Hello students, let us see here properties. This is the last properties of definite integration. Based on this, we are going to solve some problems and we do some questions on 2019. Some important questions I will make you revision. Then we will finish this chapter by tomorrow. Anyway, we have to finish by tomorrow. Then we will start area under curve. Look at here, the properties are like this. These are the last properties which left in this definite integration. Let's say here, if for x belongs to closed interval a comma b, the function f of x, g of x, h of x are defined in the intervals x belongs to a comma b close such that. What is the meaning of this? In simple language, f, g, h are three functions are there. F, g, h are three functions. They are given in order, ascending order, means f of x is less than g of x, g of x is less than h of x. Who is greater, h of x is more, then g of x, then f of x. So if you have like this order in this interval, then the integral values also same, means same way they will be having order. Like means h of x integral h of x a to b will be more, then after integral a to b g of x will be next, then integral value of a to b f of x will be next. So integral values also will be in the same order. That is the property number 1 says. What is property number 2 says? This is most important. If for x belongs to a comma b closed, f of x is such that f of x, whenever you have some function, and these two functions when we will do, you have a function. Suppose you have one question, but you are not able to integrate that problem. You are not able to integrate. So what we do here, we will see the side. We will take one side means we take one our wish, means according to our wish, our convenient, we will take two functions nearby this function. Nearby this function, we take two functions and we will find the integration of that values. That is what we are going to do it. The same way here, if this question is there, a function is there, and you are not able to integrate that time, there are the three methods are there. We will do that method. The first method was this. The second method is what? We take the minimum value of the function and maximum value of the function. And whatever the function is given, we find the maximum value, we find the minimum value of the function, we integrate them. So integration a to b f of x dx and integration a to b of this one, and we integrate this one, the values also will be in the same inequalities. Like here, this inequality, this shows maxima, this shows minimum. So after integral, if you apply, the same thing will be there. It means this value will be how much? M. If m is a constant, m comes out, and one integration of 1 is x. I substitute upper limit and lower limit. I get here b minus a. This value will be this. And you will understand more when I explain the example. And integration a to b fx dx. Fx dx and less than or equal to b. Right here capital M b minus a we can write. So this is most important one. It is asked in JEE mains. This question, this based on this, they asked in JEE mains. So we discussed on this. So this is this one, this is this one. And the property number 3, last and final one, is that if you have a modulus of integration a to b f of x dx, that value will be less than or equal to integration a to b f of x dx. When you have modulus, that value we can write like this. Another one is integration modulus a to b fx into gx dx. When you have integration modulus integration a to b fx dx is there, that value will be less than or equal to under root of integration a to b f square x dx into integration a to b g square x dx. These are the properties we have. Most using property is this. Based on this, we are going to solve some questions. Okay, you understood? Based on the property 1, let us see this question. Based on the property, I is equal to integration 0 to 1 dx upon 1 plus x power pi by 2. Then what is the answer? A option, B option, C, D given. See here, when you see this question, you can come to know this cannot be integrated. This cannot be integrated because 1 upon 1 plus x power pi by 2 is there. We cannot do integration of this one. So if you cannot do integration of this one, how to deal this one? By using the previous property. What is that property says that I am using here? 1 plus x power pi by 2, I take two functions between them. I just previous I explained, two functions between them I will take. What are the functions I am going to take here? I will take one is bigger function, one is a smaller function. Can I take this is 1 plus x square? Can I take 1 plus x square? Why? Because I have pi by 4. Options are in angles. Options angles means it should be getting in the inverse trigonometry. You know that 1 upon 1 plus x square integration is tan inverse x. So that idea I got. So according to that idea, this I can write 1 plus x square because the x value is in the interval 0 to 1. When the interval 0 to 1, this value will be lesser, right? This will be like this. So this will be this. Okay. So what I am going to get, this value is more than this value because 1 plus x square in the interval x belongs to 0 comma 1. Okay, 0 comma 1 means 0 comma 1 means what? It is a fractional part, right? So here you have. So 1 plus x power pi by 2 is greater than 1 plus x square. And one more I can write as 1 plus x. I will write 1 plus x because one more is there in log. So log is possible when if the degree is 1. So this function I have taken the surrounding of that, means side of this, side of this. I used one side of this is 1 plus x square, one side this is 1 plus x. So what I have to get here, 1 upon inequality. If I change this one upon 1 plus x square, then inequality is changes. So this will become this and this will become like this. And this will become 1 upon 1 plus x square and this will become 1 upon 1 plus x. So the numbers are like this, the function is like this. So according to the first principle, what we can do, we can integrate value also same. So use the integration. Now in the second step, use the integration of this. Integration 0 to 1, 1 upon 1 plus x. The sign will not be changed. Integration 0 to 1 upon 1 plus x power pi by 2 less than integration 0 to 1 upon 1 plus x square I get. It means this value is what? 1 upon, this is nothing but ln x, ln 1 plus x, ln 1 plus x. And you have to limit substitute 1 and 0. And here integration 0 to 1 upon 1 plus x power pi by 2. The integration of this one is tan inverse x. Tan inverse x, we substitute 1 and 0. So what I am getting, this is I am getting I. This is nothing but I, the question itself. So tan inverse 1 if I substitute, tan inverse 1 minus 0, that is 0 only. So tan inverse 1 I am getting, here I am getting ln 1 plus 1, 1 plus 1. So what I am getting here, I less than pi by 4 I got, and I got here ln 2 less than I. It means I greater than ln 2 I got. So which options are correct here? Option A correct and I greater than. Option D correct. So these two are correct. So using the first principle, we can do like this.